Well, we have a real great presentation today with Speed Muller. We're going to try something different here with having a clinic. And I know a lot of you are looking forward to it, but we have some routine stuff to do here first. And first thing, you've all been muted, and we'd like to keep you that way if at all possible. The first presentation we have today is from George Johnson, who is the head guru of the N-Scale Enthusiast. And he's going to give us a little preview of what will be coming up at the N-Scale National Convention in 2024. So George, go ahead and tell us what you got.
Tell us what I got. Well, that's an interesting comment. We're actually deep into the planning stages on Bethlehem. We are at the Wind Creek Casino and Hotel and Convention Center. We have a very large space for the Swaporama and layouts, which we're trying to do an integrated version this year rather than having separate rooms for each, which is the first time we've tried that. We learned that from the N-Scale weekend in Altoona. And we are making the cool thing about this particular hotel is that it's surrounded by railroads. There's railroads actually on four sides of it. And right behind the hotel is a yard. To the right of the hotel is a yard. To the left of the hotel, 4 blocks over, is a main line. And in front of the hotel, there's another main line. So we're kind of in the middle of a railroad junction there, which is kind of fun. The interesting part about this particular hotel is it does have restaurants inside, and there are restaurants within short walking distance as well, which we didn't have in Reno. We had restaurants inside, but we didn't have any real good fast food locations for those that like to eat and run. The main purpose of me talking to you folks this weekend is to find out what you as layout people want out of a convention. And it's more of a question than anything else. It's not really a presentation. We'll come back a little bit later and talk about what's actually going to happen there. But what we're really looking for is survey responses and input on how we actually operate for two of our major things that happen at every convention. Layout tours. Do you appreciate the fact that and in this one we have a lot, so we don't have a restricted menu of layout tours on this one. There's many layouts in the area that are within short driving distance, so that's a big advantage to this particular convention. But what we're looking for is what you want out of layout tours. Do you like to see things that are in progress? Do you only like to see finished layouts? Do you only like to see N-scale layouts, or are you of the mindset that you can learn from any scale? Those are the kinds of questions that we need to know in putting this together, because we do have a rather large number of available layouts to go visit, but we want to know which ones you want to see. Is operations an important thing? Name of the hotel. The name of the hotel is the Wind Creek Hotel. If you go to nationalnscaleconvention.com, it's the registration link for the special rate for the hotel is already up. It's in Bethlehem, Pennsylvania. The dates are from June 18th to June 23. In answer to that question. And let's see, let me look at the chat and see if I got all the answers. Yes, I think I covered everything that was in that particular question. We are looking to do expanded clinic offerings, so we need clinicians to actually be there. We are running a special convention rate for people that are participating in the layouts. It's a very discounted rate. Looks like it's going to be $25. And the reason that we're doing that is that we appreciate you putting all the effort in and bringing all of the stuff to share with people. But my question for you is, do you like to have the layouts in the hotel because you like to get together and run exclusively? Or do you like sharing with the public? Because we have to decide how we're going to handle the public show this year and see whether or not we want to do a public show, which is, always a question. We think yes, but you may have a different opinion, and whether or not that's something that all of you want to participate in and like that. In years past, we've done a lot with ZoomTRAK. We've done a lot with ZoomTRAK where somebody else is providing the tables. The hotel this year has the resources so that we can provide the tables, so that we don't have to look for a sponsor for that, which is good. We also have in years past had some challenges putting all of the layouts in there. We have plenty of space this year for layouts in the hotel. So all of those things are going on. It's been a really interesting kind of setup. We are having some difficulty with getting the right train ride to actually augment the convention for our prototype tours, but we've just made a deal where that's going to happen. So we have that taken care of, and it's going to be quite the show. we're pretty excited about it. So what we're really looking for is, yes, we will be posting a questionnaire, and we will be sending out a survey, if you will, for people that have attended our conventions in the past, and for people that want to take a look at it. So we will have everything there and actually making it so that you can actually give us feedback on what we should be doing as far as conventions go. We're running about 700 people per conventions right now. We'd like to get that up a little bit, and we need to know what we need to do to actually make it more attractive to y'all. The interesting thing about national N-scale conventions at this point, and why we don't co-locate with the NMRA, that's been a question that's come up a lot. We feel like the layout participation at the NMRA has been really, really good. Best airport is the Bethlehem Regional Airport. Or if you like driving, you can go into Philadelphia and fly and drive up from there if you want to rent a car. If you're not renting a car, there is shuttle service from the airport, the local airport, to the hotel. The reason that we don't co-locate with the NMRA, that's been a question ongoing for a very long time. The NMRA has been very good with the National Train Show as far as allowing big spaces for NTRaK and TTRAK and Fremo N and the like to actually have layouts in the train show. But the other parts of the convention, first of all, they're incredibly expensive. And second, they're very HO-centric, if you will, and they're getting less so, which is good. And maybe someday we will consider that in the future. But for right now, we feel like there's a lot of conversations that happen among N-scalers and our N-scale manufacturers that need to be in a separate location. So until that actually changes, we're going to continue to do our conventions, or the N-scale convention, as a separate entity. One of the things that's really, really a challenge in conventions at this point is hotels. Hotels are changing the way that they actually architect their spaces, and the meeting centers, which used to be a draw to get people to come to the hotel, are now becoming a profit center for hotels. So it becomes more and more expensive to actually mount a convention of this type. And the other thing that's happening to us a lot is insurance. Event insurance for an event such as ours has become quite expensive. So yeah, Lehigh Valley International Airport, Paul's right, it is AVE. The challenge with the insurance is becoming more and more difficult, especially in some states. For instance, we could not go to Florida for a convention right now because Florida insurance is about 3 times the national average. Which is unfortunate because there's some good things happening in Florida that we'd love to see, but we can't go there. We are still on our West Coast, Middle, East Coast sequence. Right now we're on the East Coast sequence, so the next one will be back in the middle, and then we go back to the West Coast after that. We're going to continue that rotation so that everybody gets a chance to bring their stuff and not have too long of a drive. So it's been a challenge over the last few years to actually get the hotel that actually can accommodate a convention of our size. So we're looking at other things in the Midwest right now, and we're looking at we're 3 years out on trying to get our locations. Cool locations in the summer, please. Yeah, I agree with that. I'm not a big fan of heat. We went to Texas a few years ago, and boy, did I melt! But it was a great convention, so it was a good trade-off. We're in Pennsylvania this year, which does have an interesting humidity challenge, but it is a little bit cooler than going to Arizona. So we're kind of okay. Our next one, it's looking a lot like it's going to be Kansas City, but I'm not officially announcing that yet because we're still in negotiation with the hotel to make sure that the thing is affordable. So that's where we are at this particular moment, and registration for the hotel is open now if you want to book your rooms early. Registration for the convention will be open on January 2nd.
Curiosity, what's public transportation to the hotel?
From where?
New York.
From New York. The jitney runs to Bethlehem to the convention. The hotel actually works with the jitney service, which usually goes to Atlantic City, but it comes that direction as well.
George.
Yeah.
You make the Swaparama public show. What's the body count of the public over the last few conventions? Is it worth it?
That's our very question as well. And we're working with a public television station, which happens to be 2 blocks away from the hotel, as our promotional partner. And to their benefit, they're going to get a portion of the gate. And we're evaluating at this particular point, using this convention as an evaluation point to see whether or not the public show is worth it. The reason that we started the public show is specifically because the manufacturers requested it, because they had a trouble justifying the expense of coming to the convention for just the 500 to 700 people that show up as attendees. And they wanted to make sure that they were actually reaching a wider audience for those people who didn't come to the convention, but still, they had to work during the week or something. They wanted to come up on the weekend. That's why we made a public show to begin with. We didn't used to have one. In the early days, we didn't have a public show at all. In fact, the Swaporama happened on Friday, and Saturday we had a big tour event that we all went on. But it turned out that our manufacturers were having some difficulty justifying their expense for coming to the show, because it isn't a multi-scale show. It's just a single scale show. And we weren't getting the manufacturer participation that we would like if we dumped the public show. So we added the public show to make them happy. And the attendance has not been stellar. We've been, getting 2,000 to 3,000 people at a maximum. And so we have some good things happening as far as our promotional in Reno. We did well. We did almost 5,000 people in Reno, but it's still not enough to justify the cost of the room on its own. So the convention ends up bearing the cost of the room. So we want to make sure that we keep our convention registration cost low, and we actually end up with more people that show up. So we're partnering with a local public television station to do pre-promotion, and we're going to benefit them by giving them part of the door.
Okay, thank you, George. To summarize then, people will be receiving an email or some sort of communications from the NSE with this questionnaire, correct?
That is correct.
All right.
Razor, before you move on, NRail provides the layouts at the convention for NSE, and anybody who wants to bring a layout or a module or both can register at layout@nrail.org.
And one thing I wanted to remind you of, George, Texas and the South are only hot if you go outside. The trick is don't go outside. We figured, most of us have figured that out.
Well, those of us from California aren't that smart. So
Yeah, I know. Okay. Well, thank you very much, George. I think everybody's looking forward to Bethlehem. We're going to move on. The next thing we have is Scale Trains has got some new stuff, and we have a video that's going to give us an introduction to what they have. Bruce, are you ready?
Hey everybody, it's Drayton from Scale Trains, and I just want to say thanks so much for having us on the podcast. We wanted to do something a little bit different for this episode and kind of give you a rundown of all the new things going on here in N-Scale. And right behind me, we have some of our N-Scale Tier 4 GEOs. There's a lot of people looking for some in-stock models. We have some of our Tier 4s, and some of these road numbers are really cool. In fact, one of the BNSF road numbers has a unique Burlington Northern sticker on the side of it, and I didn't notice it until I was looking at it yesterday, and I was amazed at the detail. So
Everybody needs to know
all the time with things that we find out when we unbox the models. As far as new announcements go, pre-orders are due on Monday, October 30th for the latest run of 42-foot Thrall Trinity coil steel cars. We've got some new road names and paint schemes, as well as new road numbers so that you can continue to build your roster. Two of the road names that I think are really cool in this run, Ferromex and also CIGX, which is pretty cool because, for you guys that have leasers, these road names are really great for leasing. In addition, as far as locomotives go, there are 14 paint scheme variations for the latest run of Dash 9s, and man, they're incredible. I'm a Norfolk Southern guy. I like the variety there with the thoroughbred paint scheme, but also being able to get the primer gray ones added to my roster. And of course, if you're also unable to wait, we have some N-Scale top hats in stock. So if you don't want to wait for another pre-order, we've got some top hat Dash 9s in stock now in the horsehead paint scheme, which is pretty cool. So those are the new announcements, and then new arrivals coming in. We have the latest run, actually the first run, the long-awaited first run of Rivet Counter N-Scale EMD SD40-2s. Some great road names and paint schemes some classic and contemporary versions for you guys, including the Norfolk Southern Admiral Cab and the CSX SpongeBob Square Cab versions. Really excited about those. For you more classic modelers, we've got Burlington Northern, Union Pacific, Southern Railway. So you're going to want to check out those road names. They're going to be here soon, so if you didn't get a chance to pre-order one, we always order extras. Just click the link in the video description if the podcast has one. I'm sure they will. If not, just go to scaletrains.com. You'll be able to see our newest arrivals. We're expecting those to arrive here within the first couple of weeks of November, actually probably a little closer to the first week of November. So with that, I just want to say thanks again for having us on the podcast. We'll see you next time in the next Manufacturer Spotlight. See you later.
Thank you very much. Okay, it's only a quarter after and we're moving along fine. But before we start Speed's presentation, Speed, are there any setup instructions they need to do to get ready before you actually start your presentation?
Well, so you gave them the instructions to download the software, to buy the kit, and to plug it in. So on the first or second slide of my presentation, we will walk through those things. There is a place they need to go to download the code that they're going to need, as well as the presentation PDF file. So as soon as I can share, then we can make that happen.
We're ready for you if you're ready to rock and roll.
Okay, give me just 12 seconds. I'm going to share this. If you go to Tom X-Ray Nancy, Apple Mary India Baker.com, that is txnumup.com, you will find this link here that you would need to click on. And once you do that, you will be inside a zip file in GitHub. And then on the far right, there's this little yellow button. Well, it's yellow here. There's a download button on the far right. So I'm just going to click here to show you. See this thing on the right here? If you click that, it will download the raw zip file, and then you need to download that. So let me download it to show you. Here comes the file. Going to open up the zip file, which shows up here. You're going to take all these files here, Control Copy, and we're going to stick it into our Arduino folder, which I believe is C, users, your own name, my documents, Arduino, and we're going to create a folder here called ZoomTRAK and paste that there. And you'll know why I'm rushing through it. I need to get to this file. So once you have this file open, then there's the presentation. And if I go to slide number 2, you will see the same link you need to click on. So what you really want to go to is type this link in,
Right there.
tinyurl.32 Nancy 8 Frank Charlie 8 K for kilo. And once you get there, you click this yellow. I colored it yellow so you can see it. You click this download button in the far right. It's going to be a weird experience because you're actually inside a zip file in GitHub when you click this tiny URL. It's not how we usually use GitHub as such, but this gets you the quickest to download the file onto your own downloads folder. And then you unzip it into the Arduino IDE's sketch folder.
Is there anybody that's trying to do that that's not ready yet? Sounds like everybody's good, Speed.
Okay, so I'm going to switch over my camera. Let's stop share for a second so I can get myself on the big screen. and switch the video to this guy over here. And then you'll see what we're going to attempt to build once this is all done. And this is not just some fancy campsite in the wild. This is in real Africa. And it's also in N scale. Let me just see how I can focus this thing. So you'll notice that in the trees, there are some fireflies, which will be the last step of this. And then once it gets dark, there's a little light sensor right here, photoresistive light sensor. As soon as I put my finger over that, you'll notice that the campfire starts flickering there, and the marshmallow comes to the fire. And if I take my finger away, you'll see the marshmallow disappears, and the fire takes some time to die out. And at the same time, you still have these fireflies doing their random things at random times. The other one sits in the smaller tree trunk over here. So no magic. Everything, if you follow along, you'll have this in your own on your own layout. So here is the little breadboard, which I'll show step by step for you to build. And there's the Arduino Uno, and I covered up the right lights with some tissue paper because they just make it way too bright. And you'll notice that there's a few things blinking in the background there. One of them is because it's telling data back to the computer, and the other one is the heartbeat, and I think it's set to 90 beats per minute. And I always like to have a heartbeat so that I know that something's running when the campfire is not working. So, okay, so let's switch back to the presentation. Any questions? Remember, the only dumb question is the one you didn't ask.
We just had a question. Somebody's asking, where is the Arduino folder? Where's the Arduino folder that we have to install the files?
Okay, so if you open up your Arduino IDE and you go to
Someone pasted it in chat.
File Preferences, then it will show you the default folder, and there's a browse button to the far right. And that's one of the reasons why we always suggest you install the latest tool for the clinic. Yes, 1.8 will also make a campfire with s'mores and fireflies, but 1.8 does not have a browse button to the right of where your folder is. So if you click on that browse button, it should pop up where your Arduino files usually go, so you can do file open and get there quickly. So just create a folder called ZoomTRAK and stick all the Arduino files in that zip file inside there. Okay, Mr. John Wallace, I have a view of you, so if you can just give me a thumbs up when I ask a question, then I would know. So I'm going to go to the next slide. Do you see a breadboard with a yellow and red LED? Okay, so in the PDF file that's in that folder, please get yourself to this page. I think it's page 3, and you need to build this while we're all talking. And the instructions are there. It tells you how to connect the red and yellow LED into the middle of the breadboard, how to stick the 1 kilo ohm resistors from the, I think it's the flat side. These LEDs have a flat side, and if you look into the light with the LED, you'll see it's the bigger part. That's called the cathode, and it has the shorter lead. You want to stick a resistor in there and go to the blue bar, which is then connected to a purple wire, connected to a blue bar, connected to a black wire. And these colors were not chosen to be specifically purple and black, no other for the reason that that's what you have in the kit, because you do not have 2 black wires. Otherwise, you would have used 2 black wires to get the ground connection. But since we're not going to use the purple to bridge it across. And then the white wire goes to 5 volts on the Arduino, connects in, and then a blue one to the anode, which is the longer pin, the round side. You can see the little round part here. And then the green wire goes over to the yellow LED. And if you do mess the green and blue up, it's not the end of the world. We can either fix it in software, or you can just live with a random yellow different than a random red to make fire. So it's not the world's biggest disaster if you connect to the wrong LED. That said, I would like to tell you that I am a native African. I grew up in Namibia. which is the country just north of South Africa, who's playing in the World Cup right now. So if you hear some yelling in the background here, that's because we might be winning against New Zealand. It's next to Botswana, south of Angola, and we touch Zambia and a tiny little tip to Zimbabwe, right where the Victoria Falls are. I modeled the TX NUMUP, which is not the Texas NUMUP. Receive and transmit is RX and TX, and therefore the Trans NUMUP, who's the real railroad, I represent as the TX NUMUP. Why do I not call it the Trans NUMUP? Because I don't want to get in trouble when I say something wrong on Facebook. It's very, very tough to be waterboarded in a country when you go home where water is the scarcest resource. I'll leave it at that. If you don't care, don't like electronics, and don't want to be bothered, write these three things down and then take that nap. Fortunately, I can only see a few of you, but usually when someone falls asleep, I will help you recover from that. These slides are all with titles at the top. The orange ones and the green ones are information and more information. And when it's blue, that means that you need to do something. Okay, so first thing is to set the computer up, which hopefully you've done. Download the installer from the Arduino.cc website. There's a long lawyer story on why it's not .com or .net or .org. That's homework for you to do. You plug the Arduino in, and in the old days, we had device driver problems. You had to install the CH340 driver from a Chinese knockoff board if you had one. If you paid $60 for your Arduino, you should be good. And if you have a fairly new computer, then you should not have any trouble either. Then there's the link again to go to. There's to download the zip file and then unzip these to your Arduino sketch location as you see at File Preferences. Okay, at any point if you need a question, then rather stop me than wait 5 slides later and then we're on a different topic. All agree? Good. Here's the Arduino 2.2.1, which you download from the Arduino website. I just tried to install it on my Windows 7 machine here that I'm using in the Helix, and no go. So I would have to go back to an older software release, which is, you can get that from the link at the bottom. Mostly I use these on Linux machines, so it's a little different setup routine, but also a little bit more forgiving. So, and then before we really start, we need to change some settings to make life a little easier for us. So please click on File, Preferences. And if you were building breadboard now, I would like you to stop and pay attention for a second, because you need to go check the boxes for compile and upload and make sure that the compiler warnings are set to default. And there's the browse button to the far right, and it shows you see users, your username, documents, Arduino. That's where your default Arduino location would be. When you do file save as, it's going to venture over there. In most clinics where I do hands-on, I ask people to just drag the folder from a thumb drive to the desktop, but then they have to click on the file open button, and they have to venture to the desktop, into the ZoomTRAK, into the code, into 01 for the first file, and then open the sketch. So if you put it here, I save you a few clicks.
Can the link you have there ends with Arduino? Can you have another subdirectory, say, called software?
You can change that location. That's just your default go-to location, and then inside of it you can have many more subfolders to get to. Like, you'll notice when we open up the first one, in our case, you're going to have to go into ZoomTRAK, then code, then 01 blink with serial something. So you are going to go 3 levels deeper than what this is. This is not the one place where all your files live. There has to be folders with the files in it. You'll see in a minute that I'm going to tell you, if you save a sketch as 1.ino, that has to live in a folder that's called 1. And therefore, you cannot use funny characters like exclamation marks, because I don't think folders can contain exclamation marks. So you're limited by what you could call a file, because it also depends what the folder structure allows. Does that answer your question?
Well, the sketches would be in /Arduino/software/ whatever the sketch is.
A folder name and then the sketches inside of that.
Yeah. Yeah,
And
yeah.
now you're going to have a folder that's called code, and then the sketches would be inside of that. So they can all live in the same place. They're just in a deeper structure in the tree or the root. Copy? So if you add software there, that's okay. Just make sure that software exists. You don't want to put a folder here that is not exist yet, because this tool won't create you the folder.
Well, the reason I'm asking is because somehow or other that extra subdirectory louses me up when I try to do libraries.
Yes, libraries has its libraries can be in two places, either inside that folder /libraries or in the program files where you install the Arduino /libraries. And there is a long list of things that happen if you have two libraries in two places, and the library that you really want is not in one of those places. So once we get to the second clinic and we need to install the servo library, I will explain what's the easiest way to get a library in. You'll notice that we have a folder with libraries, but there's a zip file in it. And I much rather want you to say, add a library from that zip file, and then it goes and it puts it in the place it wants it to, not you moving the files to different places. Let the tool decide where it would like to have that custom library. Okay, next screen. Now for the missing introduction. Even though this is a beginner's clinic, I am not going to tell you what is an Arduino. It's a chip on a board with a society of people and millions of lines of code and free tools, and we just use it because we love it. There are many Arduino beginners clinics on the internet that you can go watch for free at your own time on what is an Arduino. How did it come about? Same story. Long history. People on the boardwalks, what do you call those planks that they walk to when they model new dresses? I forgot the name of the thing, but anyway, they wanted lights on their butterfly. Catwalk,
runway.
Catwalk or runway. So they wanted to have lights on their little things, and they didn't want to create an RS-232 transceiver to a computer so that they can program a chip with a EEPROM UV eraser. So they set forth and created something that's easy for most people to use. I'm not going to say all, because that covers 7 billion people. So what is a microcontroller? Think of it as a humongous computer that's sliced up into 1 million pieces, and you just have a tiny little controller. It's not just a logic thing that does things because it's logically connected to that. It looks at instructions to execute what it's doing. It doesn't have gigabytes of RAM, so it's not a microprocessor. Okay, how is a Raspberry Pi different, or is a Pi better? Not for today's discussion. It depends on what you want to do and how much money you got and how much patience you have. You will likely use open software, the Arduino IDE as a tool. Yes, that's true. And you can go get the source code for this IDE that we're using. If you think open folder is spelled wrong, you can literally go fix that. You need one of the many choices to use as an Arduino platform. We decided the Arduino Uno. Not only did it come first, but we also wanted to save some costs, so we bought the $15 version. Before we had supply chain issues and epidemic, you could have bought an Arduino Nano for a mere 99 cents. So that would have been a better choice at that time. You might like a shield plugged in to provide more functionality. I used to have lots of slides on what shields are and how they're different than hats and how they're different than capes. Just know a shield is something that plugs in on top of an Arduino, and you can imagine that the Uno, being first, has the most of those things. And they give you something like a motor driver or a Wi-Fi connectivity, or they give you a CAN bus or an audio amplifier or MP3 decoder, so you can play sounds into an amplifier that will make noise when something happens on your layout. And the Uno being first and being a kind of decent sized platform, there are thousands of shields for them. You need code, either write, copy, edit, to compile and upload onto the microcontroller. Yes, you do. 99% of all people that can get involved in the Arduino world never write a single line of code. So if you do modify code today, you haven't written one yet. So at some point, if you would like to add a line of code, then you become one of the 1%. Game on. So, and yes, it's just C or C++ code with hundreds of libraries of code available. It is not some big name of Arduino code or some sketch code or however it got here from processing and another language that they call these things. It is simply C code. And if you disagree from me, then you need to explain to me why are all the libraries in a source folder that only contains .cpp and .h files. There's not .ino files there, none. And why, you need to explain to me, we're using the AVR GNU C++ compiler called AVR GCC. Okay, now, if you do not know anything about Arduino and you do need to get some information from somewhere that covers all these things that I just talked about, you should watch this 90-minute video on YouTube. Forgot the guy's name, but that's a good one to watch as a beginner if you want to get the full string from how from nothing to something to go. Okay, so where do we start? Remember blue, you do something. Please plug the Arduino in to that USB cable and witness that you get a solid light and a blinking light.
Yeah.
And if you've messed with it already, you might not have a blinking light, but the solid light should still be there. And if you've messed with it quite a bit, then you might have a fast blinking light. And the colors here are wink, wink, because I just noticed that mine is red and it's blinking red. It's not green and blinking orange. So depending on the version of board you got, you should likely have some color that's on, that's the power LED, and a blinking LED that's on pin 13. There are two more LEDs while you're plugging in and witnessing that. The other two LEDs are for receive and transmit as data comes to the Arduino from your computer. There will be a light blinking. And if your Arduino is generating data to either something spontaneous or you told it to say something, then that TX light would be blinking. Okay, let's see if we can get 5 hands for having it plugged in.
A quick question going back to the resistors.
Go ahead.
You're using a very large resistor, so that means your LEDs are not going to carry the 20 milliamps, right? They're probably going to carry about a quarter of that.
I set a whole slide aside for that question.
Okay.
Okay. And I will pre-say this before we get there. If you buy a modern day 0402 LED and you put more than 5 milliamps through it, your eye is going to hurt. I promise you. Okay. So when we get to that slide, I will tell you that the data sheet says what's the maximum current you should not carry full time.
How about
20
30-year-old LEDs?
Then yes. So now if that's the case, then just stick another 1 kilo ohm right in parallel of it, and you're back to 500 ohms, and you double the current and you double the lumens. Okay. So we will talk about that on that slide. Does that answer it? And
yeah.
No, you will not get 20 milliamps. I'd agree to that. Okay, where did we get this? We bought it from that link, or later that link, and both the links are still working, and they still have it for sale, even though they tell you only a few left by now. But still a pretty good deal.
Can I ask you on the Arduino itself?
Yes.
If I drew 20 milliamps from every single output on the entire device, will that burn it out?
You won't, because it cannot deliver that. Okay, so
but it's rated for 20 per pin.
One pin, yes, but the pins are also grouped into ports, and there's also a limit on how much a port can deliver.
Do you know what that limit is?
We would have to open up the data sheet for that specific package of that ATmega 328P or PU or PC apart and then
Uh-huh.
look what's the grouping of the current.
So it's a
But-
group. It's a group of pins.
Yeah. So
20.
so one, the pin can only give so much, and it has a different current for sinking or a different current for sourcing. So you need to make sure you're setting the current in the correct way. Then it's by group. A certain bunch of ports forms a group, and the groups have a limit. And then the chip itself has a wattage limit on how high you can get the temperature in the chip. You also do not want to exceed that. So you don't want to physically burn the chip up. And then the whole board has a voltage regulator on it that also has its limit. And if you use an older computer with a USB cable, you limit it to 500 milliamps. Because the computer will go kadunk if you
Yeah.
pull more than that. So it's great to make a set of blinking LEDs. You just make your computer go kadunk, kadink, kadunk, kadink, and the lights blink on and off, right? That works perfectly for the case, but not so much for the computer.
But for the Arduino you suggest we buy, is there a spec sheet available for that one?
We would have to zoom in on that chip that's on the board, because remember the picture they show here might not be what you got. So we would have to zoom in, find that chip, make sure that Microchip, who bought Atmel, is now making that chip, get an up-to-date data sheet for it, and then see what that data sheet tells you.
Okay.
But if it's made by a knockoff company somewhere else in a far, far away land, then you're at risk. But that Uno is probably a $4 part. So wire it all up and see how much firework we create. And if it works, you're in.
Yeah, but this Uno that we bought in that kit, I'm sure, is a far away El Cheapo.
Yeah, so let's make it work for us. Okay, so the picture that we show here has the DIP socketed chip, dual inline package. If you look down at your board, you might discover that it's a surface mount square package. So you can imagine bigger chips might allow more current to go, smaller chips, a little tighter, they don't have all the heat sinking allowed. Okay, so this is what you just plugged in. And this information is available, and it's so available that you can get the schematics for it. You can get the PC board layout for it. You could actually make your own Arduino Unos that looks exactly like that. I would just suggest that you take the Arduino logo off and you put your own logo on. Because we want to be proud of you, right? Not the guys who invented this. Come on. You don't want to just make a complete copy. Just at least put your credentials on there. So what's important here is that we care about the A0 through A5 in this dark, I don't know if you call it maroon color here. That's the numbers that we care about. And we care about the D1, D2, all the way to D13, as well as 18 and 19 up there. Those blue numbers that we care about. I'll show you on the next slide what are some of these different numbers. And that also corresponds to the numbers that's printed on the board itself. So if you take a magnifying glass, you'll see it says here RX and TX, which is the function of those two pins, but it's D0 and D1. Now, from experience, pick some other pins before you start messing with those, because those are used to talk to the chip that programs this chip. You see this tiny little black square in the top right? That's another Atmega chip that makes USB talk serial to your computer. So when you send code down or you send data down, it goes to this chip first, and then RX and TX, and then it comes in over here. So if you start blinking LEDs on D0 and D1, you might lose communication to the device. Regardless, ports have pin numbers. In a DIP socket, it starts at the top left. That's pin 1. All the way around, that might be pin 28. On the square one that's on your board, pin 1 starts on one side. There's usually a little circle on the plastic, and then the ones goes, I believe, counterclockwise. Yeah, counterclockwise from 1 to 32, whatever. And now you hear there's different number of pins. It depends on the package, what functionality you might get. So some Arduinos might have a D18 and 19, and some might not. Like if you buy the Micro or the Nano, there's other pins available there that's not available here. But it's the same chip that can do the same thing. You might just have to solder to another place to get that same functionality if you did buy the wrong board. Not beginner stuff, so don't worry about too much. All you need to know is when you look at this picture, look at the blue column or the numbers on the board, or the maroon brown column here and the numbers on the board.
So what does this chart tell us when we look at the other colors other than the blue and the brown?
Okay, so this chart tells you that right here where A0 comes in, that's on port C, bit 0, or the 0th bit in the port. It is also hooked up to a functionality called PC interrupt 8. So if you want to have an interrupt in use, then you would use interrupt 8, or would like to use interrupt 8, then you would connect the wire to A0, and then ADC0 is the same as A0. That's the analog to digital converter A0. Similar up here where you have PC6, this tells me that there could be a way where you could configure that pin to not be a reset pin, but be an input pin, so you can read if pin 6 or PC6 is high or low in port C. But by default, it's the reset pin. If you press that, the code goes back to the beginning and execute from that. So if you look here on the far right, you'll see SCL and SDA. That's the serial clock and serial data. If you use the SPI interface, the I2C interface, and then SCK, SS, MOSI, and MISO, master in, slave out, master out, slave in. Very bad terms in today's world. That's the SPI interface. So if you connect it to an accelerometer that's going to give you lots of data, then you would like to connect that accelerometer to these pins over here. What's also important is that most boards have a little tilde, a little squiggly symbol here, like by D9. Those are the PWM pins, and they will allow you to output a pulse width modulated signal at, let's say, 10% or 20% or 50%, and that would then increase the brightness of your LED as you make the PWM have a higher value in it. Make sense?
Yeah.
So before we understand this whole thing, you need an electronic engineering course as well. Okay. How are we doing on time? 10 minutes to go, right? We haven't even blinked the LED yet. Next screen. How do we get to the next screen? Like so. Here is a schematic view of pin D13 or 13. That's where that LED that's on your board. You'll also notice that they call it the built-in LED now in the code. That pin is connected to pin 17 on this P chip. That would be the DIP, I assume. And that's connected to port B, the 5th bit. And it's also serial clock in the MISO, MOSI, and SS SPI system, if you were to use that. No harm if you have an LED flickering while it's sending clock and data to something else. I used to explain on this slide that if you're going to make your own Arduinos and you want to make your own tiny little board because it fits in a Fuller little N-scale bus, then you can't stick an Uno in there. You cannot stick a Nano in there. You cannot stick a micro in there. You have to make your own board. And then you're going to have to buy these chips. And these chips comes with different acronyms at the end. It's important that you buy a P or a PU, and you need to know why. So that's for more advanced. Okay, let's do the first example. You start the software, tools, board, Arduino AVR boards, Arduino Uno. You make those selections under tools for board. Then you go to tools port, and you select COM or TTY USB or TTY ACM or CU.serial if you have a Mac. And now you have an Arduino Uno connected to a USB enabled COM port. And you go to File, Examples, 01 Basics, Blink, and you should load this little file here. So I need 5 hands, and then we continue. Next screen, with the file, Examples, Basics, Blink loaded, press Control and R. And if you have a Mac, it's Command and R. Or in the top left corner of your screen, it is a check mark. They used to call it verify. Click the check mark button, and then you'll see some stuff running in the back, in the black part at the bottom of your screen. And if you scroll back up there, you'll see the compiler and all the lines of code that the computer is running to compile the code into this .cpp.o file, and eventually it generates a .hex file, I think, and then it generates a .bin file. And then when you click the upload button, which is the button that has an arrow to the right, second one top left, then you will upload that .bin file into your Arduino, And once it's done uploading, it might verify that it's good, and then it will tell the thing with a reset, you can run now. You also get at the very end how big your sketch is, 2% of program storage space. The chip has room for putting program in, and I don't know how 9 bytes is 0%, but maybe it was 0.9% and they rounded it down or something. So you're using 9 bytes of dynamic memory because the microcontroller has also memory where you can store variables in. The maximum is 2049. We're using a whopping 9 of those. Okay, so now I'm going to ask you to change some of those numbers. Let's quickly talk about what the code does. There is a main.cpp, and that's why people don't think it's C code, because they don't see the main.cpp. Main.cpp sets the chip up. It then calls this setup routine that you're staring at one time. And then it goes into a for loop, and it continues to call that loop function called void loop over and over and over. But it also checks in the meantime if serial data came in to reset the chip and upload new code. So there's a little bit more happening there that you cannot just go create main.cpp and do something one time and do a lot of things over and over, because you also have to give the bootloader time to bring new code in. Now, eventually, when you make millions of these for heart-lung machines, then you don't need a bootloader thing, or maybe you do. But in this case here, setup is called once. So we tell pin mode LED built in would be 13 to be an output. That means that that little pin on port B bit 7, which comes out as pin 17, is now be configured to be an output pin. So it's going to give you a voltage that's either 0 volts or 5 volts. And it's 5 volts when you set it to high, and it's 0 volts when you set it to low. So the pin mode command is a function call, and it says configure this pin. And then when it calls loop over and over and over, it does a digital write to pin 13, which is LED built in, and it sets it to high. Then it delays the processor. It says, brakes on. We wait for 1,000 milliseconds, and we do nothing else. And then we say, digital write, LED built in, to go low. And again, brakes on, 1,000 milliseconds, do nothing. Eventually, we're going to talk about that, because that's a lot of nothing that the chip is not doing, and we could have been doing something else. Okay, so now, because you are so adventurous, you're going to change these numbers from 1,000 to 250, and from 1,000 to 750, and then you give me a thumbs up if you notice a difference. John, you saw a difference, or you have a question? Dick, you have it working, blinking? And this is where I walk through the clinic and I hand out the certificates of you are now an embedded software or firmware engineer, because you modified some code and you uploaded it. Congratulations. Ready for the next? The C language, and in this case of the Arduino, has a bunch of functions that's defined, like pin mode, makes it input or output, digital write it high or low, read the pin, store that in a value, digital read, the pin number, analog write, that PWM pin, you could put a value in there, either 0 through 1024 or 0 to 2048. I don't remember the real detail right now, but that says make the pin this much brighter or this much dimmer, depending on how wide the PWM part is on. If you put it at 100%, then it would be always on. If you put it 0%, it would be always off. And anything in the middle, like 50%, would be halfway on, halfway off. Delay, which is the stepchild of wasting time, says how many milliseconds. And then millis, which is the better choice, we'll get to that in a few minutes, is to say how much time have expired. Because you can say, has it been a day yet? Yes. So open the cat feeder so that the cat gets food. 10 seconds later, has 10 seconds expired? Close the cat feeder and then wait for another day. Maybe a day minus 10 seconds, so that a full cycle is 24 hours. Okay. Then the rest of the stuff that listed down here is the, they have a word for it, and it's called control structures. So if the variable x is bigger than 5, then do something. while something is true, then do all these things. For, meaning if j is set to 0 and j is less than 10, then go through the loop and make j one more. And once j hits 10, then 10 is not less than 10, then we bail out of it. So we can do something for a few times and we can count how many times. The map is important to us because we want to read a value from the light sensor, and the light sensor can go from 0 to 1024, and we want to map it to a number that says 10 degrees to 15 degrees for the servo. So how do we get 100 to 500 to map to 15 and 25? And you use the map function for that. And the answer to that gets stored in the now I have a blank. In the variable called val. Random, you tell it, give me a random number, and you can say what's the minimum and what's the maximum, and you have to give it one more. If you want the number to be one of the random numbers to be 100, you have to say, give me a value between 0 and 101. So that will include the 0, but it will include 100 and not 101. And you do that when you say, oh, we need to wait a random number of times, or we need to put a random number of light into the LED so the PWM can do random things. And isn't that what we want for a fire? Okay, so the other language was called wiring. So wiring processing, I say, just think of it as C and C++. You can buy any beginner's book for C, C++, and move on. If you go to arduino.cc reference/en for English, you'll get the language reference. There's the structure for setup and loop, the control instructions for if, for, switch, while, do, break, continue, and return, as well as the variables that's predefined for you, high, low, input, LED built-in, true and false, the data types, voids, booleans, characters, unsigned characters, integers, long integers, unsigned integers, and so forth. And then the functions that we mostly use, pin mode, digital write, digital read, analog IO, analog reference, analog read, analog write, and then due and zero products only have analog read resolution and analog write resolution. So, any questions? Next page. Variables is things in memory that stores numbers, in our case, or maybe strings, but a string is just a number because it's an ASCII values, which is just a number again. And all you need to know, it's ones and zeros that goes into predefined size of boxes. So the C, C++ languages define what these variables can be called. What I like to do is say what kind of variable it is. So I say it's an unsigned 8-bit value, and it's called value, or temperature. Or if it's a signed one, which means it can go negative, then I would call it I16 value or temperature, because I want to know that it's 16 when I go do some special math or shift some bits across a bit register. Then it's important what the size of the thing is. You typically don't want to do math with all kinds of different kinds of variables. And if you add and subtract things, you also want to make sure that the biggest guy gets the attention as well. There's this thing called camel case where we use English words to say, this is my first variable. And then we capitalize the first letter of each of the words in that variable, because we cannot use spaces, because a space is the thing that splits things from a command to a variable. So space is not allowed. A lot of people use underscores, like you can see the uint8 underscore t there. That's also a good way to go, but it's a lot quicker to type shift and V for value than underscore. And now you still have to decide if it's going to be a big V or a small v following that. Okay, so enough of this. Let's go. In the folders that you downloaded and unzipped, there's one called 001 underscore blink slow with serial.ino inside the code /001 blink slow with serial folder. So I'm going to wait a little longer here to make sure that everybody at least gets to that. You have to say file open and then go find that ZoomTRAK folder, then the code folder, and then the 001 blink slow with serial folder. And you'll notice that this is not much different than the blink example that we provided. It's just that the code is formatted a little differently. I put spaces before and after variable names, unless there's a comma. I put spaces within any empty parentheses. So when I do add something in there, I already have one space to start with. And then that LED built-in thing was not there 10 years ago. So I just called it LED pin is 13. You could have used LED built-in instead of LED pin. And then the part that's added here is the serial object that we create, and we give it a baud rate with the begin command, and then we print line an empty line. I'll tell you in a second why. And then we print line the string called version_string. And that's not shown here, but when you open your file, you'll see what version_string is. And I think I show it here as underscore blink slow with serial, comma ZoomTRAK, comma 2023 1028. So once you have this compiled and uploaded, I didn't mention it yet, but when you do the upload button, it compiles as well. So you need to get out of the habit of compiling and uploading. You can just compile and upload. So use the right arrow most of the time, except for when you don't have the UNO connected and you want to compile to see if it's able to compile. Then you just click the verify button, or under the I think it's under tools or under sketch, there's a menu item for compile. And then you have to open up the serial port monitor. At some point on there was Control-Shift-M, or you go under tools, serial port monitor. And the first thing you need to do is change the baud rate to be 115200, because 9600 is a little bit 1980s, maybe 1990s. Anybody knows, they can correct me. And when you change the baud rate, it also sends a reset to the board. And that reset of connecting with a serial port is important, because if a device is not working the way you think, and you think you're going to connect a computer to it to inspect what's happening, you need to remember that when you connect that computer, you open up the serial port, it will send a reset to the chip. And now your trouble might disappear. So you need to find another way of connecting to it without getting the reset happening, if you're really serious about catching the problem in the act. Okay, so why do we sprint the string? Because some of us are very adventurous. We write code for other people, and 3 years later they bring it back and say, ain't working anymore. Well, what's on it? Did you print out the code and gave it to him as well? Did you hand him a micro SD card or a thumb drive and say, here's your code? Or was it still on that floppy drive? If you plug it into a computer and it spits the string out at you, then you know what to go search your old laptop for to find his code. It's not that hard to search through your whole computer's hard drive to find 001 blink slow with serial comma ZoomTRAK, comma 2023.10.28. And if you did this smartly, you would have had 1023.10.28 in the file name. Then it's a lot easier to find as well. Make sense? Head shakes? Everybody lost? Okay.
The baud rate is the baud rate of what? The Arduino or the computer?
It is the baud rate of the Arduino to begin with. Your computer is smart enough to adjust to that, but you are right here telling the serial port monitor what the baud rate should be. And if you see little gobbledygook characters on the screen, it's because you have the wrong baud rate. And because of the gobbledygook characters, that's why we do this empty print line, so we can go to the next line and then print our string and not append our string to the first part of the gobbledygook. That's why we do the new line, and then we say print a string. So the Arduino is already programmed to be 115200. You can see that there in this second line called serial begin 115200. And then you tell the computer to go to 115200 as well. But it will send a reset, and then you will see the message. If not, I assume that newer debugging systems, because in 2.2 and later on, they're going to add more debugging for us, so you could pause the processor and or the microcontroller and get some information from it, I assume. If you hit the reset button on the Arduino, then it should just print another string for you. Who's willing to print reset and give me a thumbs up? See if it printed. Okay, when you save a sketch, you need to know that it's going to save a sketch for you. it's a file that ends in .ino, and it has to be in a folder that that contains the same name. If you don't give it a name and you just start typing and you say save, it's going to create something that says 28 OCT and some random numbers, I guess, for October 28th. So it contains today's date. I would suggest that you change that to be a more millennium first date, and then the year, and then the month, and then the day. I know it's not an American thing to think of the $6 million check that you're going to get when you win the lottery. Would you be upset if that 6 was in the middle of all the zeros, or do you want the 6 to be in front of all the zeros? Because that 6 takes the longest to roll, and therefore it's the more important. And therefore, when you save a file name with the date in the millennium first, it's also chronologically and alphabetically in the same order. Where if you go August 05, they will appear before January 1st, because A comes before J. So how about you go 2023.01.1 or 01, and the same with time and date. Okay, so no spaces in the file names. And in the old days, you couldn't use numbers. Now they allow numbers in the front, and no funny characters. Main.cpp will call setup and loop, and that setup and loop is what's saved in your sketch. So that's why you're not writing a C file, because a C file already exists. Okay. Next one. Let's make this blink faster, and we also print out when it's on and when it's off, and we specify the time that it's on or off, or the time to the next change. Okay, just a note to the people who are putting things in the chat. I can multitask, but not as fast as the questions are coming in. So rather ask the question so everybody can hear it instead of us double surfing the. Okay, back to the mission.
Steve, could I ask a sort of question for after you build this hardware, according to the diagram we have, what's the software? Campfire? What's going to run it?
Can you see my screen? Can you see my screen right now?
Yeah.
Yep.
It says 002_blink faster.
Right.
If you unzip that whole folder with all the code, you'll notice that those numbers are going to go up as we go through this document.
Okay.
And then the very last one, I believe, is 13 is my lucky number.
All right. It's a list of software.
Last one is 015 camping all with welder.
Okay.
And where we will stop, where this is plugged in, because you do not have a blue LED, neither do you have white LEDs in the kit. So 14 is the last one.
Okay.
So 14 would be the last.
It seems to need a couple of other files other than the campfire. Like you say,
okay, so
go get library such and such and such and such.
Yeah, but we will get there, right? So I gave you the PDF, and now you have all the information.
Right.
So your question is, why are there more files? The reason there's more files is because we need 002 here, and there inside 002 is that there. And
no. If I loaded the campfire all,
yes,
if I open that up, you're going to do a few includes.
Correct.
Where do I get those includes? You know, like heartbeat.
Right.
And
right in the same folder.
I could find the files, but what do I do with them? I can only load one of those programs on the.
Okay, so when we get to object-oriented programming, I will show you how on the far right-hand side of your file name in the tool, there is a drop-down arrow to say New Tab. So go ahead and open up this 14 camping all. And when you open up camping all, you'll see more tabs on your screen that contains the other files. It's like opening up a browser, and you have several tabs at the top.
So I don't have those tabs. I have campfire.h.ino open. So now what do I look for?
You have campfire dot.
Campfire.h.ino is open in the Arduino software.
Yeah, you approached it from the wrong direction. So
I see.
I suggest that you close your IDE,
Right,
and then you open the IDE with, I assume it would load the same thing, so you don't need to close it. Just say File, Open,
right,
and go to, let's pick number 5, 005. So just say File, Open, 005, selecting, and then you select only the .ino file.
right.
And when you open that up, there should be two tabs, one with this code in it, and the other tab should have this code in it.
Okay. Now, how do I get it into the machine? Into the Arduino?
By saying upload.
But I'm going to say upload for the campfire.
You're going to say, no, you're going to say upload for 005 blink with OOP. That's what's going to get uploaded.
And what about the campfire program?
No, stop right there. I said, because you have a .h.ino file, which means that something got messed up there. Okay, so therefore I said abandon campfire and come to 005.
Okay.
And when you do 005, it's not the campfire.
Right.
It's blink with object-oriented programming. It contains two files because what you're trying to figure out is where the other files are.
Right.
Yeah, so we don't care about the campfire right now. We care about the extra files. So if you were to open up the one that says by two lights, 009, you should have the INO file, which has setup and loop, and you should have a campfire.h, and you should have a heartbeat.h.
Right.
But you never individually open these files up. You open the INO file up. And because they are all in a folder with the same name, the IDE is smart enough to also load the .h files for you in the other tabs.
Oh, okay. All right.
But if you clicked on a .h file and you then saved it, then the saving will do a save with .ino. And now you have a hiccup.
Okay.
I would delete all the code and unzip again.
Right. Okay.
That will bring you back to that. People could see my folders here on the screen. I don't know. Or you only see the presentation. Okay, yeah, it shows.
Yeah, we can see the folders as well.
Okay, so each one of these is a program, and we can quickly talk about that because people very often ask, I did get to manage a welder to work. It's on pin 13. It's on the board and it blinks just like a welder. But I need another welder. So can I change the pin number and upload another one? No. When you upload again, you're erasing the previous one and you're putting the new one in. So that's not how you add another welder. Once we get through the object-oriented programming thing, you will exactly see how we add another welder. And now you're going to appreciate the fact that you can add 13 more welders and you have 13 pins welding randomly. And you do not have to use the delay blocking thing to delay a random amount of time to get all 13 welders doing what they randomly should be doing.
The only problem is we don't actually have welders and fishermen.
Well, the welder was the welder is something that everybody wants, or they always tell you, well, I bought this welding kit and it was only $7. Why would I spend $25 on Arduino to get a welder? Well, you got a $25, or in this case, a $15 campfire, but you have 10 more pins to use. Why don't you add 10 more welders? Right? So the welder is just a freebie, right? It just comes for the ride. But if you instead want 2 fires or 4 fires, then now here's your chance to excel, right? I only have 1 fire.
That's what I was asking before, because you're using more and more pins.
Uh-huh.
And we're going to hit capacities which are unknown.
No, it's known. There's only 16 or 17 pins.
No, I'm just saying, if I load every pin with something
Yes.
and I got 20 milliamps on every pin, it's
No. I'm going to stop you right there and say, stop buying 30-year-old LEDs. Get the very bright 2 milliamp LEDs. Please.
no.
I know we have a tendency to hold on to old things, but no. Those square coupler things that's on your little plastic cars that's on the floor here somewhere. No, those got to go. They got to become micro trains with magnet uncoupling, right? Those stuttering DC ones, it's not going to run with DCC, but when you buy a new one, make sure the decoder goes in, right? There is this. Let's not hold on to the.
Yeah, well, we got hundreds of these old LEDs.
Yes, but 1,000 new ones is $5. So do you want to hold on to? Think about how much lighter you can make your town by letting that go. Right?
So you're saying the capacity of the new LEDs is 0.05 or 5 milliamps?
If
2 or 3 milliamps.
Yeah, if I go get a reel of 0402 LEDs and you can buy them with these wires already soldered to them, like these Fireflies that's on this little board here. If I turn that on full time and I put it into the camera, I'm gonna blind the camera. Of course, you see the blink there? See the blink? That is only on for a few milliseconds, and it's only on for a very it's not full brightness either. So if I just simply turn that on, you're not going to like that. You cannot look into it. And the main reason I put eventually sticky tape over this LED on the board is if you need to read the pin number there next to that power LED, it's blinding you. You cannot see that it says 13, and what's the next one? It says GND. I cannot read the GN with the light on.
So if we have a brand new modern LED, what is the optimum current that you should be using?
Well, is blue beautiful? That question is, does this dress look pretty? Is blue beautiful? There's no optimum. You, the perceiver, needs to decide that's not bright enough or that's too bright.
What's the maximum operating, like 20 milliamps on the old ones? What's the new one? Maximum.
The new ones also gives you a max current at 20 milliamps.
Oh, okay.
But you wouldn't want to put 20 milliamps through it, is what I'm getting to. The lumens are enough at 5 milliamps. It's what we say. Someone mentioned 3 milliamps. 3 milliamps is also a good number. But by 1 milliamp, you know it's on. You definitely know it's on. And that brings you to a kilo ohm resistor. Once we get to that slide. Okay, let's do a few more slides and then see if there's more questions, because I think it's more valuable that we talk about this than race through the stuff over here. So all I want to show here is that in order for us to turn things on and off on a timing sequence, we have to delay a certain amount of time. So this is nothing different than basics blink. It's just that on time and off time is now defined in a capital letter. Preprocessor will replace this situation. So instead of, let's say you had 200 of these, let's say you use 10 LEDs and you wanted to have them delayed 2000, and you decide one morning it needs to be 1800. Then you have to go search and replace all the 2000s with 1800. But if you define it as on time as 100 and off time as 1900, you go to one place at the top of your file and you change that 1900 to 1800, and you change the 100 to 200, and everywhere else down in your code, the preprocessor will replace off time with 1800 and on time with 200, and boom, you compile and it goes. So all the things that you might change, you stick them at the top so you have access to them a little easier. Instead of searching way down there for, where did I use that number that was somewhere between 200 and 220? Because we cannot search in a tool for 218 if you don't know it's 218. You have to know 218, search. You cannot say search between 200 and 220, right? But you can search for off time and see where did you use off time. Okay, so if you run this guy here, it's going to be, I guess, off for 1900, and it's going to give you a short blink at 100 milliseconds to be on. This tells you how breadboards work. The short bars, 5 pins at a time, are connected to each other. So you do not have to install a yellow wire to connect the top of the bar to the bottom of the bar. The yellow wire shows you what is connected. The red, blue at the top and the red, blue at the bottom, shown in cyan and magenta, I think it's called, those are all connected to each other, except if your PC board is long enough and it gives you those breaks as I'm showing at the bottom left. If there's a break in the blue line and then the blue line continues after a gap, then those pins connected underneath it are not connected to each other. So if you thought that the ground would run the full length of the blue on this left-hand side, not the case. You would have to install a black wire, a red wire, and at the bottom a black wire and a red wire to connect it so that you do have ground all the way through. Okay, so this is the part where you had to assemble and build the red and yellow LED. I just stuck it up earlier because some people read fast and they don't pay attention. They just want to build and get out. So that's why I gave them a chance to run with that. So purple wire connects it to blue bars. White and black comes from the Uno to the board as 5 volts and ground. And the LEDs are connected with the cathode, typically what we call the bottom side, to a resistor to ground. And then the high side or the anode, we stick into an Arduino pin, in this case, ~5 and ~6. And for those who care about currents flowing, this is not the best way to drive an LED because that pin can sink more current than it can source current. In this case, we're putting the pin high to source the current. But if we were to flip the thing around, we could sink more current and have brighter LEDs.
Can I ask a quick question?
Yes, sir.
The white wire is connected to, it's 5 volts, is connected to the bottom row of slots. Nothing else is connected to that.
Yet. Nothing is connected yet.
Okay.
If I ask you to install the white wire later, I have to remember that. But if you put it in now, while the board is brand new, empty, it's a lot easier to do it right now. And I can fast forward the slides and you will see we're going to use it right over. As soon as we install the light sensor, that white wire is using. As soon as you plug the servo in, we will use the red wire on the servo, and that's why we're not using the red wire here. Remember, at limited resources, we only have so many colors, and we only have one of each. If you had a whole bucket or you bought the bigger kit, they sell bigger kits, and they cost $45, which I don't think would be appropriate for a $45 campfire. I mean, let's just build a $15 campfire, but we have to mix the colors up a little bit. Okay, so why do I put the resistor on that side of the LED? Does anybody agree that it doesn't matter if I flip the LED and the resistor? We know you cannot rotate the LED. The LED will not conduct current the other way. But why do I put the resistor to ground? Does it matter?
No.
Current flows through both of them. It doesn't matter which one it hits first. And when we say first, we also don't know which way the current is really going, right? Because current could be a magical thing. The electrons actually flow the opposite direction than what we believe, if you can trust them, right? It's all this conspiracy theory about which way does it really go. The good news is, as long as it goes, it lights up, and that's what we want, so we don't care. Why do I put the resistor to ground? Because I also make PC boards. And if I need to bring a voltmeter to a board and I need to stick the voltmeter's black wire to ground, guess what? I know the resistor goes to ground. And the one side is to the LED, so the side that's away from the LED is a good place to stick my voltmeter's probe. And then I can use the red one and go measure voltages at other places. Seems like a fair plan, right? Okay, here's the slide about LEDs. If you are not willing to read data sheets, the slide is not for you. If you have a hard time believing that 30 milliamps is needed because the current says it's a 30 milliamp LED, then this slide is not for you either. Then you need to believe in the world that says it's a 12 volt LED. Okay, there is a group that thinks there are 12 volt LEDs, but this slide here is for people who are willing to understand that LEDs were discovered by accident. They were making a PN junction diode, and when they turned the lights off, they noticed that, well, it's glowing a little red over there. What is that? Well, it was kind of infrared at the time, but they had a little glow red because light is not generated in a single frequency. It makes a little spectrum around it, and so the infrared LED was touching the red part of light, and they saw the red, and then so they discovered you can make LEDs from this. So as the atoms or the electrons spin inside an atom or a molecule, when it gets excited and it falls back, it emits a photon that is the color of that distance that it had to travel to fall back. And that is why we got red first, because that's the atoms or molecules that they were using. And it was easy for them to then do yellow and orange by finding other PN junction type materials, because you just don't take a rock and gold and create an LED, right? It still has to be a positive, negative doped thing that conducts electricity one way. It still has to be a diode. So that is also why we had to wait so long for blue LEDs, right? I mean, they could have just squeezed it tighter and make it blue, right? No, you had to find the materials to make blue. And therefore, we also don't have pure white LEDs, because a white LED is not a PN junction device that just emits white light, which means it emits all the lights, all the way from ultraviolet down to, not ultraviolet, from violet all the way down to red. And when you add those all together, then you get white. No, you take ultraviolet and you hit phosphor, and the phosphor glows white. Or you take a fairly light red one, a fairly light green one, and a fairly light blue one, and when you turn them all three on, your eye thinks it's white. But you're actually looking at red, green, and blue, right? So they say don't look into the sun, but that's a whole lot more red and orange than we think, and mostly because some of the blue got absorbed in other places. I'm not going to tell you where. So for an LED is made as a chemical device, and when this molecule says my V forward voltage for the diode is 1.9 volts, and if you exceed that, I will let red photons leave the device. So it's a 1.9 volt LED. It is not a 12 volt LED. Okay? The reason they call it a 12 volt LED is because they put an appropriate resistor with it, that when you put 12 volts across both, the resistor limits the current that goes through it to not make it blow up. Because here's something I didn't tell you. All LEDs can go white. Every one of them, for a brief second. White gone. Okay? Try it. Stick it into the wall socket. You'll see white. Be careful. Wear gloves. Okay, it's a short endeavor. It's a fun experiment. Kids love it. The orange LED is a little higher voltage. A red LED is typically in the 2.1 volt range, and a blue or white LED that is actually ultraviolet or some other form or fashion to make something glow white is in the 3 to 3.4 voltage ranges, which means that you need to exceed those voltages to get that going. So you guys will eventually learn about 5 volt devices and then 3.3 volt devices. Well, when you get to 2.1 volt devices, you're not going to blink in the white LED anymore, because 2.1 volts does not turn a blue LED on. You need something with a higher voltage to make that happen. So the math is simple. You know how much voltage is across the LED to make it turn on. And then you know the rest of the voltage from your 12 volts or your 5 volts or your 3.3 volts has to be across the resistor. And because you have V equals IR, you have to choose the current that's going to flow through this whole path to get the brightness you want. And therefore, you pick the resistor for the voltage that's now known, 5 volts minus 2.1 for green. You're left with 2.9 volts, and V equals IR says if I want 2.9 milliamps, then I need 1,000 ohms. You see how we got to 1,000 ohms?
For the ones that are being sold, white, 12 volt. And it comes with a resistor sealed in. So we don't know what the resistor is.
Correct.
What is the actual voltage, would you say, across the diode? And what would you guess the current to be?
I would guess the voltage to be in the 3.4 volt range, because that's how most LEDs are made. And depending on the manufacturer, I cannot tell you if they're putting 5 milliamps or 10 milliamps through there. If it's a fairly new LED, then 5 milliamps is bright. But you got to decide how bright you want it. So I do not know the current unless current you can measure.
It comes with a resistor, an unknown sized resistor. So
correct. So if you put 12 volts across it, you can measure the current going into it.
Okay.
With an ammeter or the part of your voltmeter that you stick into the ammeter part, a multimeter or a digital measuring device. Okay, so what you also need to know is that now you only need to buy kilo ohm resistors, because if you don't like it, it's too dim, you put another kilo ohm in parallel with it, and the current goes this way and that way, and now you have twice the current flowing. If it's too bright, you stick another kilo ohm in series with it, and now it has to go through 2 kilo ohms, and you dim it by half. And you want something in the middle? Well, you put 2 in parallel in series with 1 alone, and now you have 1.5 kilo ohms. So no need to go buy 227, 340, 512, as well as a 768, and then you try to mix and match those together to get what you like. So resistors comes with a diode in it. So it has an anode that flows current to the cathode. And that's where the triangle points you in the direction that the current will flow. Of course, electrons go the other way, they claim. And then these devices have a 5 millimeter and 3 millimeter versions have a round side and a flat side. And they have a big part in the middle and a small part in the middle and a long lead and a short lead. And I can promise you there are devices that's not manufactured with the anode being the longest lead or on the round side. If you refuse to read the data sheet, you're going to have to try it out. And if it's not what you think it is, it's just the way it is. Okay, so now we want 2 beacons. Remember, we have a red beacon and we have a yellow beacon. So now we're going to say we want to turn this beacon off, wait this long, turn that beacon off, wait all this time, turn the first one back on, turn the second one back on. And then guess what? We use repeat in loop to do it over and over. So we have these times of 250, 1850, 250 and 50 on LED pin 5 and 6, which is where your red and yellow LED are. And then every time delay runs, we pause for time 1, we pause for time 2, we pause for time 3, we pause for time 4, and we repeat the whole thing by turning them low, low, high, high, low, low, high, high. And you will see the beacons do 2 different beacons. And if you want to phase them a little further, you need to change 2 values. If you want them to be on a little longer, you have to change 2 values, and you'll quickly realize that that's a lot of values that you need to change, especially when you add beacon number 4, 5, and 6. That's a lot of numbers that your Excel spreadsheet now needs to calculate for you. So in the Arduino, there are 3 ways to do timing. The first one we already know, it's a delay. It's a blocking call, is what we call it in the software world. And the chip stops and it does nothing else. You cannot sense if someone pushed a button. You cannot make another light turn on or off while you're in a delay, because it's just sitting there waiting for a timer to expire, and then we continue. The next best way is polling. We looked on our watch. Is it time to do something? Is it time to do something? Is it time to do something? Yes. Let's do it. Is it time to do something? No. Is it time to do something? Yes. Let's do it. And so if you look often enough, you can tell everybody, was it time to flip the eggs over, time to rotate the toast, time to turn the steak, time to turn the swimming pool pump on or off, time to go check the mail, time to change the oil in the car, the windshield washer fluid. And you can see that you can do all these things by checking is it time to do something, which is not the best way. The best way is to use interrupts and timers to say, hey, I'm going to forget about you. I'm going to slam the door shut, press the 60-second button and say start. And the milk's going to spin in the microwave. And when 60 seconds go by, you hear ding and you get interrupted and you go get it. The toaster pops up and you go get the toast. And the coffee says, ding dong, all done. You get interrupted. The problem on these tiny little microcontrollers is that we only have 3 timers to generate timer interrupts with. So we don't have 19 timers to do 19 campfire lights with. So polling with millis it is. And if you want to learn more about the interrupts and how interrupts work on the Arduino, there's a link for you right there. So polling with millis has this little hiccup that it has a number that runs every millisecond. It goes up 1 since you start the chip or since you reset the chip. And then in about 49.7 days, it overflows and it goes back to 0. Now, if you keep your layout ready running for 49.7 days, I need an invite. Okay, because I want to participate in that too. But if you shut it down after 4 hours and you only start it up tomorrow night again, or you only have an operating session every 2 weeks, I still want an invite, but not a problem because you're going to cycle power before the 49 days run out. Fortunately, we use the code in a way where we don't even care about the 49. So if it does overflow, when we do the minus and compare with the time, then problem solved. Okay, so what we're basically doing is saying, what is the time now? And then we check every so often, has more than X time expired. So let's say your eggs were put in a pan and you need to put it for 3 minutes. So you put the egg minute, no, not in a pan, you boil eggs, right? Sorry. You put it in and then you check, is it 3 minutes yet? Is it 3 minutes yet? Is it 3 minutes yet? Because we don't have the interrupt to ping us after 3 minutes. We have to get as close as we can to the 3 minutes to do what we need to do. So when we do it and we want to do another egg, then we just reset the time and we check again let's say every 10 seconds, and then plus minus 10 seconds, we would know when we get to 3 minutes. Okay, so here's the code for doing the beginning of the heartbeat thing. And what we do different here is we don't set the pin high or we set the pin low. We use the digital read to read what the pin is. Even though it's still an output, we know what value we write to it. So we know we set it high. And then we invert that. And then we say output that inversion. So if it was high, write low. And if it was low, then write high. And we put that in a function called toggle. You remember I said the setup is a function being called and loop is a function being called over and over and over. Well, now we're going to call toggle from our little loop down here. And we're going to say now is the time. And now is minus previous is bigger than time 1. And time 1 is 500. Then make previous now and toggle the LED pin. And if it wasn't, we just get out of loop, we come back into loop and we check again. So we do this continuous cycle. And when it's time to do something, we do something.
So you can have loops inside of loops?
Correct.
Oh, I thought we were limited to that one
No.
loop of void loop.
You just don't want to call loop itself. You don't want to recursively call yourself because you need a way to get back out again. And when you say we call loops inside loops, you also do not want a loop that's going to run 10 hours before it comes back and continue the rest of the first loop, right? You need to limit yourself on how fast you want this loop to run. So if I call another function that says calculate the time it will take to go to the moon and 7 times around Mars and come back, and that calculation is going to take 10 hours to do the math, then how am I going to blink this LED every 3 minutes if I'm busy doing something else? So you need to be able to give this thing time to loop, right? So
So when you have the 2 loops, each one has its own instance, so to speak, right? Because the function name is the same.
No. Hold on. We're not creating another loop here. This is the loop. There's
Now,
only
down
one
at the
loop.
bottom, you say loop. You
No,
see the
down at
very
the
last
down at the
line.
bottom. Down at the bottom, I say comment loop.
I understand comment, but you mean you, even though there's comment there, you do mean to say you can put a loop there.
No. What I do in my world of writing code is when I say void toggle, at the end of that function, I put a comment, this was void toggle, and it takes a uint8. And so when loop starts up here, at the end of loop, I say, this is the end of loop.
Oh,
Because if you have long loops and you have more curly braces in it with switch statements and if then else statements and for loops, I want to know when the for loop ends. So I put
right.
//for.
So you can't have a loop inside a loop.
Well, you can call loop, but you cannot redefine loop. You cannot create a new void loop. But inside loop, you can say go call loop again.
So I can make a call to loop inside a loop.
Yeah, you just need a way to get out of the second call.
Loop. Yeah.
And then get out of the first loop.
Right.
So that's called recursive calling, where you call yourself, but you need a way to get out. So if you don't have an if, don't do recursive, because you're just going to fill up there what they call the stack, and your chip is going to reboot and start over, and you're going to think it works fine, but it's not actually working fine. It's just rebooting. Now, some people do write code. Like I've seen plenty of speedometers where someone has the code running that when we get to the end of the speedometer, measure your train speed, they just hit they send a reset command, and the Arduino just starts over. I mean, no real big problem. I mean, you saw the speed, and then the screen blinks, and it goes back to waiting for another train. Some of us do that. We turn a voltmeter on, we measure a voltmeter, and then we turn a voltmeter off. And for the next metering, we turn it back on again. Isn't that rebooting? But it's dangerous coding because it might reset anytime. Okay, so in this code here, I created a bug deliberately so that you could not compile this. Right? Because you also need to realize that things can go wrong. And what happens when it goes wrong? So who can tell me what's wrong in this code? And don't look at the next slide. That's cheating. It's not obvious, and when you compile, it will kind of give you a hint for it. So if you guys are still here with a computer and would like to compile, it will say you are missing
a semicolon.
A semicolon. And can you tell where? There's a beautiful red line there that tells you.
Yeah.
Right? Okay. Every statement needs to end with a semicolon. And if it doesn't, it means it's part of a bigger thing. Or still part of the sentence. Because you can put enters anywhere and it's still code. And that's something you're going to learn over time. It's not something we can explain to beginners, that I could press enter right in front of this exclamation mark in front of it, and I can press enter, it goes to a new line, and it will actually do the exact same thing, because the line starts and the line continues, and when it hits the semicolon, then the instruction stops. Okay?
Yeah,
but be careful doing that.
My compiler was objecting to the hash mark in front of define.
Really?
Yeah.
Okay, see what the quotation mark looks like. Because if you copy paste it, and that's further down the slides, whenever we copy paste from a Word document or the internet, the quote marks become those curly quotes. You cannot use curly quotes. You need to use straight quotes. Okay? Have it solved your problem? What happens if you open up you don't have a double O? Never fix. You have to add the semicolon and compile again.
Okay. Let's go back and.
We are going to have to stop shortly.
Okay.
Actually, you guys. Well, no, yeah. Once I leave, that's it. It's going to shut down the meeting. So
Bruce, you can press Window L and let us be.
So you're going to continue this next month?
We probably won't be doing it next month. We're gonna have, but we've got Speed has promised to come back, so we haven't scheduled the next session yet, but we'll certainly have at least one more session.
Okay, let me quickly then run through these so you can maybe work on your own, and I can show you where the benefit come to this and how we get closer to 13 or 14. Next slide will tell you what object-oriented programming is. You already use that by serial.begin and serial.println. So it's not a new thing. It just takes code and it takes its variables and it stick it in a thing, and you declare it as a class and you instantiate it as an object. And if you want another object of that kind, then you just give it its initialization things, and then you have another object. So when we do heartbeat, that's something I like to have on all my projects. So I know that something blinks, it means the code is running. And if it stops blinking, I know the code is in trouble, because your server could be broken and then your server is not moving anymore. But if it's blinking, you know the code is thinking. Okay, here's a quick tour of heartbeat. All we end up doing is instantiating this object, and we end up with this function called update, where we from loop, we call the update function, and this thing checks the time, and it checks is it's time to turn off or is it time to turn on. So instead of having that code in loop, because if we create 15 beacons, you have to copy those things 15 times, and you end up with all that code to control 15 beacons, versus you could have had 15 beacons dot update, and each of them just runs update, and it runs the same code over here. So here you instantiate a beacon and a heartbeat, all coming from heartbeat. So you'll see that it's still calling the heartbeat thing, but you call the one beacon, the other one heartbeat, and you give it different times to do their thing, so that the beacon is only briefly on and then off for 2 seconds, and then briefly on and off for 2 seconds, where the heartbeat goes, 80 beats per minute. And then this is how we do it. Beacon.begin, myheart.begin, beacon.update, heartbeat.update, and it continues myheart update. And the benefit of this is that now we can check for other things. Did someone push a button? Did someone change the light sensor value? While the beacon is still doing the beacon thing every time we get through loop at that point. So this explains PWM, so you can do your analog writes to make your LED dimmer. Random, this is the instructions for how random is using. Campfire has a random thing in it, and now the software would become a problem if you randomly have to turn something on or off. That it means that when you have your beacon every second, then if you were to doing the blocking delay, you would need to subtract that random number that you collected from the 1 second for the beacon, and then you have to delay the rest of the time and then turn the beacon on. And then you have to randomly make sure that you give that random thing a time again, and then subtract it from the beacon from the beacon to do that again. So that's what Campfire shows you, and then Campfire by 2 LEDs. And so now we have a Campfire 1 and a Campfire 2, and we end up with Campfire 1.update, Campfire 2.update, and myheart.update. Analog read is how we're going to read the light sensor. We're adding the light sensor. Here's the white wire for 5 volts in use by putting the light sensor in there. And then we do an analog read for the light sensor. We use the serial plotter. This was a tool that I wish I had when I came to the States in 1997, because who would write a plotter for you to read your data coming from a serial port? These guys just gave it to us for free. So now you can watch the light as you put your hand over it, how it goes up and down, or you can measure the temperature, and it will show you where the temperature is going, all in one little plotter for you right there. Then I will go over what Servos does, how we install the servo library, and then the servo gives you all these methods. Also, again, object-oriented program. So you say servo.attach the pin number, and then servo write with the value. And then we connect the servo, and we go through all of that. then we add the Fireflies. So you also need to go find 2 white LEDs somewhere else, or someone mentioned to me that Fireflies are actually yellow. So I hope there's more than 1 yellow LED in, so you could substitute yellow LEDs for that. Same value resistor. Just a note that for the light sensor, we use a 10 kilo ohm light resistor down there and not a 1 kilo ohm resistor. And that's why I separated the two, so you could see that. And then we make the fire fade out at the end, and you will get to see what the schematics look like. This tool called fritzing, which makes these beautiful pictures like this. At the same time you're doing this, you get a view of the schematics. You have to go draw the lines in and give them colors again for the wires. And what you didn't know either is that at the same time it's placing these parts on a little PC board for you. And then you have to go right to trace the copper things. And then from that PC board file, you can actually click buy and order yourself a bunch of PC boards that has these parts for you to solder in holes for. And if you pick a 0402 LED, then it would be not holes, but little pads for you to do that. For those who ask about the rest of the kit, you have all these other parts in there as well. The bottom thing has the Dropbox link for their code. Be careful when you install their libraries and stuff. It might mess up your system. So maybe just download the files and hold on to it until we're done here. And the big question is always is, what would you like to do? And that would bring us to how you power these things. Your USB port out of your computer, if it's not USB C or 3 or something, if it's a 2.0 USB port or 1.1, you will not drive more than 4 servos vehemently at the same time by using 500 milliamps. So if you do plan to make more than 3 servos, then make sure you get 5 volts from somewhere else. Actually, 6 volts or 5.5 volts are better for servos. I like that more. Most servos are specified between 4.5 volts and 6 volts. And your computer's USB port is not the place. In the very first Arduino clinic that I ever gave, the question came up that we have this beautiful welder now, but I cannot borrow this computer for another 2 weeks to have a welder in the train room. That's a problem, right? Because the welder is powered by the computer. So the very next clinic, I changed it over. So first thing we do is, because back then you still had to solder the pins into the Arduino Nano. So we cut 2 pins off, and in that V in and ground corner, we would put a 9-volt battery connector, and then we would plug the 9-volt battery in to show you that you can power the thing before we turn the computer on.
How much power would we get out of a 9-volt battery?
It depends on what you're doing. I would not use a 9-volt battery, but that's because it's 6 tiny little 1.5 volt cells wrapped in a metal wrapper. You should actually take a 9-volt battery apart and see what's inside there. It's quite surprising. It's quite surprising that they make 1.5 volt cells that small. Now you can buy AAAs, you can buy 4As, and I've seen 5As for sale as well. And it's just shrinking. You end up with a little hearing aid battery, right?
Yeah. I ran a Thomas the Tank Engine on a 9-volt battery, ran about an hour in N-scale.
Good. But
So
then the battery is dead, right?
Yes. But it'll run a surprising amount of stuff. They used to run radios on these things.
Indeed.
All right, Speed, thank you very much. Really appreciate this. And we will post the material. We'll probably send out an email to everybody to let you know what we've posted so far, and maybe repeat Speed's email address if he doesn't mind. And so if you have questions. So anyway, thank you very much, and we'll see you.
Thank you.
Next month.
Isamura.
Speed, can you hear me okay?
Yes, sir.
All right, J.M. Gadori here, producer of the NRail channel on YouTube. And I can promise you that after post-production, we'll have this a nice clean version of what we did today. And I'm looking forward to collaborating with you. You and I met way back at Amherst earlier this year. And I think you do wonderful work within the NMRA and within your own community as well. But I believe that what we're learning here, plus the tools, I mean, I have right in front of me the actual kit. I ordered it. It came in this week, and I have in front of me on my laptop the Sketch October 28A Arduino 2.2.1 that uploaded perfectly last night. So I started today with everything that we were told by email in advance of this that we needed to do in order to actually create the little product, the finished product that you were describing. And I believe we're not far away from being able to accomplish that. So I just want to commit to you that we will have something very fancy, very handy, very practical that folks will be able to follow point by point and be able to do exactly what you showed us to do today.
And how do I find that YouTube channel?
I didn't hear that question.
I said, how do I find the YouTube channel where you're going to put this?
Just go to NRail. You just literally write the words NRail into a search box on YouTube. YouTube itself is a website, youtube.com. If you just do a /NRail, it will take you directly to our channel. And on that channel, you will find that there are several playlists. The most prominent playlist is called ZoomTRAK, which is what we're doing today. So this episode of ZoomTRAK, about 30 days after this broadcast, it will be published for everyone to see. And not only that, but we will also index what we're doing and update our index on the nrail.org website. So everything here is going to be searchable. Consider what's done today as a platform that we'll all be able to build on top of and go from there.
In 30 days.
We always wait 30 days. There's a reason for that. I don't mind telling you what the reason is. We all are members of NRail, but not everyone who's a member gets to see this wonderful broadcast, especially in its final form. And I can tell you as the producer of the NRail channel, what I do in post-production with this very video is takes me about an 8-hour day of post-production to clean it up and get it ready. And I love to do it. And it's a wonderful service to the community. And frankly, I learn more than you could possibly imagine just by doing that process. And I hope, and I've gotten many feedbacks. I know you do too. So that's what's coming.
Well, let's see if I can back up to them first.
All right, Speed, I'm going to go.
We've got a lot of people have their mics on that we're getting a lot of feedback. So if you're not needing to be talking to everybody, please be sure that you're muted. Speed, thank you very much for your presentation today. If people need to get a hold of you or have questions after the fact, is there a way you'd like them to do that?
Easy. If you're an NRail member, get yourself into the interchange and you'll see me there. If not, my email address was in the notice that was sent. I think gertmul@gmail.com, GERTMUL@gmail.com. And if you forget all of that, not bragging, but I'm the IT department head for the NRail. So if you go to nrrail.org and you scroll to the very bottom, you'll see there's a blue footer and it says organization and structure. And if you click on that link there, you get all the officers, all the board of directors, and eventually you get to the people that do some of the work, and the IT department head is right there, and my email address is next to it.
Very good. Well, Speed, thank you very much. You had me completely confused after about 30 seconds, but that's because I'm old and forgetful, and it brings up bad memories. I'm glad to do that kind of stuff.
I was aiming for 20 seconds.
Yeah, well, all right. Folks, remember we do this every month. Be sure and tell your friends that are not members of NRail that they can have the opportunity to see this stuff live as it happens every month, but they do have to be sure they have a membership with NRail. And it's easy to do. You go to the website and you log in, and you go on and I don't know, Bruce, you can tell them how to join. But
just go to the nrail.org website and there's a big button that says join us, and just click on that. And in fact, if you do so before the end of the year, you can use the NTRAK 50 and get in for the $5 first year new member price.
All right. So again,
and also, Razor, just one quick thing that's mentioning that with the holidays coming up, that's a great way of treating one of your Railfan friends just buy them a membership in NRail. And it doesn't cost very much, and they will, I'm sure, be appreciative of it. So you can recognize people that way just by going ahead and getting them an NRail membership.
All right. Well, thank you all very much for attending this month, and we'll see you next month. Good night.
Yep.
Or good
Thank
evening.
you.